Hi, everyone. My name is Mihir Bhaskar. I'm a research scientist at the AWS Center for Quantum Networking. Before I dive into what we do there, I want to give a bird's eye view of quantum technologies at AWS. So at AWS, we're investing in the long-term potential of quantum technologies, and that comes in many forms. First, we created and launched Amazon Bracket. It's a fully managed service integrated with the AWS cloud that you can use today and gives access to a variety of quantum computers and really allows customers to play around and test hardware. Second, we launched the Amazon Quantum Solutions Lab, a professional services team of subject matter experts who can help AWS customers understand how they might leverage quantum technologies for their business. Third, and very importantly to our overall approach to quantum computing and quantum technologies, we launched the Center for Quantum Computing in 2019 in partnership with Caltech. And this is where we do research and development with the goal of delivering a fault-tolerant quantum computer. And finally, what I want to talk to you about today is the Center for Quantum Networking, which we launched this year. And this is where we, similar to the Center for Quantum Computing, do long-term research and development of technologies that we think could enable next-generation secure communications and cloud services. So first of all, you might be wondering why a company like AWS is interested in carrying out R&D to build quantum networks. First and foremost, it's because our customers are asking us, what should we do to prepare for a future where we have large-scale fault-tolerant computers, quantum computers? Well, we know very well from, as we've heard already, that quantum computers can pose a threat to certain encryption systems. And I want to mention that AWS is already very heavily involved in developing, validating, and deploying post-quantum cryptography. Even prior to NIST standardization, AWS Key Management Services has already incorporated post-quantum algorithms in a trial capacity that allows customers to begin preparing for these new encryption systems that will play a very important role in responding to potential threats of quantum computers. However, PQC is an approach that relies on computational assumptions, which could in principle be invalidated with any future advances in computing technologies. So to get fully information theoretic security, where we know the distributed keys will be secure forever, we need to use a physical key distribution technique. And this is where quantum key distribution comes in. If we can transmit quantum states between remote parties, then they can establish these future-proof, verifiably secure encryption keys. However, quantum key distribution is just the first technology available when we start thinking about being able to send quantum states over a network. And really the goal of the AWS Center for Quantum Networking is to explore the entire spectrum of capabilities of an advanced quantum network. In particular, a quantum network that's operating on a size, a scale, and a topology that's relevant for the AWS business and its customers. And so these kinds of networks, we can imagine, enable end-to-end entanglement delivery. And in such a network, not only do you get the advantages of information theoretic security of QKD, but you also have improved privacy. So the end users of the network, they share entangled states, and they don't need to trust any of the infrastructure providers or anything else that happens in the network. They can really trust the validity of that entangled state. So this enables improved privacy. We've also heard that distributing these entanglement between quantum modules is also a way of scaling up quantum computers, similarly to the way that our most powerful supercomputers are classical supercomputers are networks of CPUs. And finally, there's the potential for a fully blind quantum computing. If a customer has a high sensitivity compute workload, they would ordinarily need to maintain their own on-premises infrastructure. This might be especially challenging with quantum computing. So if quantum customers can access a quantum computer over a quantum network, they can submit their tasks to the cloud privately, enabling fully blind computing. So there's a number of potentially exciting applications, but this needs to be taken with a very large grain of salt. That these applications are very, very nascent and very, very far away. So the goal of the AWS Center for Quantum Networking is to take a long-term perspective and lead the development of these technologies, both the hardware and the applications. So in that vein, one of our first initiatives is a very recently announced research alliance with the Harvard Quantum Initiative. So we're funding targeted research that we believe is really key to enabling quantum networks, providing resources for state-of-the-art fabrication for relevant devices, and probably most importantly, providing funding and scholarships at many levels, so undergraduate, graduate, postdoctoral, to help build the workforce of scientists and engineers that we believe will be bringing quantum technologies to commercial readiness over the coming decades. And so together with the AWS Center for Quantum Computing, now the Center for Quantum Networking, we really have a long-term vision for this nascent technology. And our goal is to assemble a leading team to solve these key R&D challenges and then make these technologies ready for the cloud and impactful for our customers. So with that, thank you for your attention. I have a couple of relevant links that you can take down, and I'll turn the conversation back over to Mark.